He's waking the vehicle up, and shortly it will go into balanced mode, where it will balance its two drivable wheels, so we're insisting on some landing wheels in front once it goes down. It's just checking sending the signal. He's going to interrupt from pushing the signal. Now it's going into balance mode, and it will slowly move forward to its parking position. We're trying to simulate here that it would go down, an aisle of a parking lot and turn at the end, and then go around and come to the parking space and park in it. Once it's in the spot, it will turn around, do a 360, turn on a dime, so that it's ready to point out the right way for the next maneuver, which is automated retrieval. Landing on its front nose wheels and going into park. The next step is the reverse of that, which is automated retrieval. You'll see it wake up soon, go into balance mode, and then move off and come towards cruise. Breeze just press the retrieve button on his smartphone, and that should wake up the NV. So this is a feature that I think people can relate to, where let's say you've just left your restaurant and you want the vehicle to come and pick you up, like valet parking. It could save you a lot of time, and if the weather's not very good, certainly can. But there's also a societal benefit from vehicles that can go and park themselves, and that is that a lot of energy is wasted today by vehicles looking for parking. It's estimated a third of gasoline is consumed in congested conditions by vehicles circling to look for parking. So now the vehicle is landing. That completes the first feature we wanted to demonstrate, which is the automated parking retrieval. The next feature we're going to be demonstrating is platooning. We have two vehicles. In order to demonstrate this, we have to bring the second vehicle up to the first vehicle so they can start off at the right orientation and location. Tom is about to enter the vehicle. He's going to not actually be driving the vehicle, but he's just in case as a safeguard. But he won't be controlling any of the vehicle. He'll just be sitting in the vehicle. He is getting into the red vehicle, and he's going to manually drive it to the starting point for the next demonstration. These vehicles can drive manually and autonomously, which we think is very important. We're not taking any choice away from anybody, but there are occasions where you'd like the vehicle to drive itself, just as there are occasions where you would like to ride it. I think these type of vehicles, it's a fun experience. both modes. These vehicles are fun to drive because they're so maneuverable. They have an electric drivetrain, but they're also fun to ride in because you're doing something more than just driving. To transfer between autonomous and manual mode, you have to bring the vehicle to a stop and then press a button, and that switches the mode. So the blue vehicle was designed in our Australia studio in Melbourne. GM has a design studio in Melbourne, Australia, and the red one was designed in Rüsselsheim, which is near Frankfurt, which is our European studio. The design also incorporates a Chinese opera mask graphic on the red one. And then the grey one, which you'll see driving later, was designed in our California studio in Los Angeles. They're meant to represent that there's a lot of design freedom with autonomous vehicles and electric vehicles. Our lead designer from California Design Studio is here, UC. So UC is here to and can answer any questions you may have on the vehicles and on the design side. So Bree's going to get into another vehicle. I think it's the grey vehicle. The grey and the red vehicles both have driver controls that can toggle between the left and the right hand side, so that both people can drive.
This one's open.
Here, vehicle-to-vehicle collision avoidance. You see that the blue vehicle is following its programmed path, autonomously unmanned, and Cree is then driving the vehicle to intercept the path that it's driving on. And the blue vehicle stops when that happens because of vehicle-to-vehicle communications. And then when the grey vehicle is no longer blocking its path, then the blue vehicle continues on. This is all done using vehicle-to-vehicle communications. It's not relying on sensing technology to perform this. The sensing technology is more relevant for vehicle-to-pedestrian collision avoidance, which we'll demonstrate later. So that concludes the vehicle-to-vehicle collision avoidance. see how maneuverable the vehicles are. You can turn on a dime. They feel a lot faster than they actually are driving. It's a very maneuverable and sitting feeling inside these vehicles.